Hello and good day, everyone. I'm Ujjwal Gadaraju. I'm an assistant professor at the Web Information Systems Group here at TU Delft. And it's my pleasure to welcome all of you again to the third edition of the Academic Fringe Festival. And this one's on designing at scale with human AI collaboration. We can harness unprecedented amounts of data using AI today, and we can create opportunities to tackle major societal problems in numerous domains. We've been exploring some of these upcoming ideas in the space of health and well-being, and we've also talked a lot about how this can make quite a dent in the mobility sector. But to make AI useful, we need to find new ways to combine the creative powers of humans with the analytical capabilities of computers. And while designing solutions and developing systems for societal good, a key challenge lies in finding out how exactly we can help designers or experts and societal stakeholders in working together with AI to prepare, realize, and evaluate any interventions that we can construe. So how exactly can we reduce this design complexity for large-scale social interventions? Well, through the course of this particular edition of the Academic Fringe Festival, we will discuss these interesting breeds of challenges. In the last few weeks, we kicked this off with Ben Schneiderman. We've had interesting discussions with the likes of Chen Hao Tan and Juho Kim. And just a little while ago, we had Aaron Halfaker on here at TAF as well. And we've been having excellent discussions around human-centered AI. This week, I'm absolutely thrilled to introduce our next speaker in this series. This is Nithya Sambasivan, who will address the question of what is the view of the world that guides AI development in high-risk areas and how this view regards the complexity of the real world. So very pertinent discussion to be had on this topic. Dr. Nithya is a socio-technical researcher, whose work is in solving hard, socially important design problems impacting marginalized communities in the global South. I, for one, can't think of a better person to have on at this edition of TAF, and I'm extremely ecstatic that this is the second time Nithya has accepted our invitation, and she's the first one to do this for a second time. So thanks again, Nithya. Dr. Sambasivan's work has also been widely covered in venues like VentureBeat, Scroll.in, O'Reilly, The New Scientist, State of AI Report. I can go on and on, but I'd rather not cut into some of the time that Nithya has here. And I'd just like to welcome you once again, Nithya, and I can't wait to hear everything you have to share with us. Over to you.
Thank you, Ujjwal, for the really gracious and generous introduction. It's my pleasure to be back here and looking forward to the dialogue here. So let me get started with presenting my slides first. Can you confirm that you can see?
Yes, that would be great. Thank you.
All right. So my talk today is on the myopia of moral centrism in the field of AI and machine learning, and talking about designing at scale. These are my talk today presents empirical insights and perspectives on how AI and machine learning operates at large, particularly in low resource communities and in higher stakes areas. So it's a pretty longish talk. So I appreciate any clarification questions in the middle, and to hold off on any big questions until the very end. So let me start with this quote from the Indian philosopher Jiddu Krishnamurti. What is important is to put forth a fundamental question, not to find an answer. And if we're capable of looking at the fundamental question without seeking an answer, then the very observation of the fundamental brings about an understanding. So in this talk, I present my research insights and ask a few fundamental questions about how AI is developed and impacts the humans involved, particularly the most vulnerable. And I hope to leave you with several open-ended questions for which there may not be immediate answers, but hopefully thought-provoking. So many scholars argue that AI research and practice today places novel model development, which is mathematical algorithms, at the center of the field. New model architectures and bigger and better state-of-the-art performances are celebrated within the field. Criticism has been raised even by AI researchers about how the overt emphasis on models has reached a point of ridicule. Some call it alchemy, empirical challenges to be won, incremental, and leaderboards. While AI and machine learning communities lionize models, dataset work is rejected in leading conferences, which illustrates to us what is considered science and what is not, and what is valued and what is not. AI models are also reported to be measured against clean and large data sets that don't contain any noise in order to report high performances in academic papers and in proofs of concept. But the real world is dynamic and ever-changing. Early progress in AI, which is the low-hanging fruit of quantity alone, no longer applies to harder, subjective, higher stakes problems like cancer predictions. AI is increasingly applied to high stakes domains with critical safety impacts on living beings. Several of these high stakes projects seek to intervene in low resource areas in fragile and complex domains. For example, a vision statement from one of the AI researchers that we interviewed was to diagnose tuberculosis from X-rays in 15 seconds instead of the baseline of 10 days, and in regions with one doctor per 30,000 people. Now, impressive as this goal is, several AI projects that are high stakes in nature are also high modernist, which means that they demonstrate a strong confidence in the potential for scientific and technological progress as a means to reorder the natural world. So it is against this backdrop that I situate my research. Resource constraints make several aspects legible in inquiry. Several humans are enrolled in service of the machine in low resource areas in the form of domain experts, annotators, field partners, and even users. And the downstream impacts of these projects on the communities can be huge, regardless of the success or the failure of these projects. So specifically, I have been interested in answering the questions of how is the machine made? What does the process include and exclude? What are the practices of developers in building AI systems in high stakes areas? How are the crucial non-model aspects, that is data, labor, expertise, fairness, seen by developers in their system development? How are the various human contributors perceived and engaged with by AI developers? And what do the developer practices tell us about whether AI is even a good fit for high stakes applications? So in order to answer these questions, I've been studying up AI researchers and practitioners, building high stakes, cutting edge technology in low resource areas around the world. So studying up is a technique from anthropology of observing the practices of professionals, and also in my case, quite literally moving up the ML pipeline. So today's talk reports from a couple of projects, a qualitative study with AI researchers in the US, India, and various sub-Saharan African countries, as well as a study with scholars and activists working on social justice in India on their concerns on responsible AI. My vantage point is that of a socio-technical researcher with a background in HCI and ICT for development, having worked with marginalized communities in the global south in building technology for the past 15 years. I will discuss both the technical aspects of how these systems are built and the socio-political aspects of how humans are involved and impacted by these systems in the global south. So in this talk, I'm going to cover data cascades, which may be a little bit familiar to some of you from the previous talk, descaling of domain expertise, and reimagining algorithmic fairness, concluding with some implications for AI development, both for AI researchers as well as other communities such as HCI, CSCW, and interdisciplinary collaborations as to what are our practical implications and open questions for us here. So starting with data cascades in AI, this is a paper with several other Google researchers. This was awarded a Best of Chi last year. Data is the critical infrastructure that's necessary to build AI systems. Data can determine performance, fairness, robustness, safety, and scalability of AI systems. Paradoxically, for AI researchers, data is the least incentivized aspect, and the data work is viewed as operational relative to the glamorous work of building models. Data is often viewed as a database, licensing, or a legal issue, but we believe that human-computer interaction has an important role to play in elevating data work as a first-class citizen of building AI systems. So in our paper, we observe and define data cascades as compounding events that cause negative downstream effects from data issues that can result in technical debt over time. In our study, and again, recall that this is a study that was done with high-stakes AI practitioners around the world, 92% of our participants reported experiencing at least one data cascade, and 45% experienced 2 or more cascades. Data cascades are complex, they occur frequently and persistently. They're opaque in their diagnosis and manifestation with no clear tools or indicators to detect and measure the effects. In fact, a number of practitioners use system-level metrics like F1 score to measure the success of these systems and don't have data set-specific metrics. Data cascades are triggered when conventional AI practices are applied in high-stakes domains, like viewing data as operations, moving fast, hacking model performance without consideration for data quality, or undervaluing domain expertise and labor. Data cascades have negative impacts on the AI development process, including causing harm to communities, burnout of relationships, discarding entire data sets. Cascades are often avoidable, though, through stepwise and early interventions in the development process. So we observe 4 types of cascades in the paper, and I will discuss 2 here for brevity, starting with interacting with the physical world and the brittleness around it. High-stakes AI systems are typically brittle in that they closely interact with previously undigitized environments like air quality sensing, ocean sensing, or ultrasound scanning, leading to even more reasons for an AI model to break, like limited training data, complex underlying phenomena, volatile domains, and changes to regulations. Cascades here can appear in the form of hardware, environmental, and human knowledge drifts. As an example, even the slightest movement of a traffic camera due to environmental conditions can result in an AI model failure, one that could have detected traffic patterns and violations and accidents on a highway. Artifacts like fingerprints, shadows, dust on the lens, improper lighting, and pen markings were reported to affect model predictions. Rain and wind can move image sensors in the wild, leading to incorrect results. Now, a conventional AI practice of training models on pristine data sets that are tailor-made for high performance, but deployed in the messy real world appear to trigger these cascades. And the cascades of this type took the longest to manifest, taking almost 2 to 3 years to emerge, almost always in deployment and in production. Another type of cascade comes from lack of cross-organizational documentation between various relationships within the organization, with field partners, with data collectors, and with external sources. Practitioners describe several instances where collected and inherited data sets can lack critical details. And the missing metadata can lead AI practitioners to make faulty assumptions, ultimately leading to costly discarding of the data and harm to beneficiaries. So as an example, one AI practitioner talked about how a lack of metadata and collaborators changing the schema of the data set led to 4 months of precious medical robotics data collection. As high-stakes data tends to be niche and specific with various underlying standards and conventions in data collection, even minute changes can render data sets unusable. A conventional AI practice of neglecting the value of data documentation and field partners not being made aware of the constraints in achieving good quality AI appears to set off these cascades. Cascades here became visible through manual reviews, often by chance and not through systematic process. The impacts of the cascades here can include wasted time and effort being blocked on models and discarding entire data sets. So our results indicate the sobering prevalence of messy, protracted, and opaque data cascades, troublingly in high-stakes areas. Data cascades point to the contours of a larger problem in AI and machine learning. Residual conventions and perceptions of ML that are drawn from the world of big data, of abundant digital resources, of model valorization, of moving fast to proof of concept, and of viewing data as dirty work in ML workflows. We need to move towards a proactive focus on the practices, politics, and values of humans of the data pipeline. We need to move from the current approach of goodness of fit to a model to goodness of the data set as well. From collecting more and doing more with data to doing better with the data that we already have. We need to innovate on structural incentives to recognize and reward data work in conference tracks through organizational recognition of data work, through greater collaboration and transparency between ML practitioners and domain experts, shared benefits for all stakeholders, and more. And the next portion of the talk will get into more of this. Data ethics and practical data work, oversight boards like IRB, which actually I'm not sure what the European equivalent is, but the regulatory board for human subjects research, and ethics standards should be a part of AI education and praxis. Finally, we need greater data equity in the global south, where we observed that as a study was conducted across multiple countries around the world, we see that access to models and the education around AI is relatively democratically available across the world because of the availability of pre-trained models and free resources online. But it is with data and compute power where we see the greatest disparities. More work needs to be done here to close the inequities around the world. So this work has led to a bunch of impact. It led to the rewriting of the data chapter in the PAIR guidebook, which is now a state-of-the-art set of guidelines on working with data in machine learning throughout the pipeline. New RIPS introduced a dataset track. This is a recommendation that we make in the paper, calling for larger structural changes in AI. And the work also opened up a new research agenda of creating interfaces, policies, and processes for data excellence in AI, and was implemented in 10 Google products. So moving to the second portion of my talk on the de-skilling of domain expertise in AI and machine learning. This work was also conducted with using the same methodology of interviewing AI practitioners in high-stakes areas around the world, but with a focus on expertise, domain expertise, and labor. So this is a collaboration with Rajesh Veeraraghavan from Georgetown. Field workers are necessary for, and I forgot to mention, this is an upcoming paper at CHI in a few weeks. Field workers are necessary for AI projects in areas with poor infrastructure, where there are limited data sets available. Now, again, contrast this with several well-resourced Western contexts where there is, there may be pre-existing data sets or public data sets that are already available, but for a practitioner that works in low-resource areas, they often have to go develop a data set from scratch. Now, it is standard procedure in AI in low-resource areas to partner with field organizations and their workers, like community health workers, agricultural extension workers, who play a crucial role in both the bootstrapping of the models as well as in the deployment of these systems. These field workers are known to be underpaid and overworked. For example, an ASHA worker, who's a community health worker in India, performs a mind-boggling array of 720 tasks, and AI data collection is often additional to their primary responsibilities. However, the domain experts like the field worker are chronically undervalued in the history of AI. Here's an illustrative quote from NLP researcher Frederick Jelinek on his disregard for domain expertise in building language models. Every time I fire a linguist, the performance of the speech recognizer goes up. Given that models seek to emulate and aggregate local expertise from field workers, to what extent is the worker's expertise acknowledged, engaged with, or credited by the AI developer in building the model? This was our research question. Our results show that despite the mastery and the tacit knowledge of field workers that takes decades to build, and that which the AI model seeks to emulate through data set collection, AI developers seem to reduce field workers to data collectors for their uber expert models. We find that most developers do not have any first-hand contact with, provide training, or compensate field workers for their data labor. With the absence of direct interactions with workers in most cases, the work of a field worker was primarily read through their dataset artifacts. AI developers attributed poor data quality to poor work practices of field workers. Workers were perceived to come in the way of the worthwhile model development efforts of developers. We present 4 conceptions of field workers as held by developers: workers as corrupt, lazy, non-compliant, and as the data set itself, that is, workers as being referred to outcomes and outputs in the interviews and not as human beings. Despite the limited engagement and first-hand understanding of field workers, developers created several disciplinary interventions to influence field workers to collect better quality data in the form of surveillance, gamification, cross-verification, and pre-processing fixes. So to borrow from political anthropologist James Ferguson, data collection in AI operates here as an anti-politics machine, making political decisions about what constitutes expertise and creating technical solutions to technical problems through management interventions to influence field workers to collect better quality data. We argue that AI development in low resource areas de-skills and invisibilizes domain experts. Field workers should be accurately viewed as domain experts with special knowledge and mastery in their local contexts. Even though the models in our study sought to emulate and improve over the expertise of local workers, the workers' expertise itself was treated as non-essential knowledge by the developers. The workers' knowledge, networks, and capabilities were viewed as simply assets for dataset collection rather than necessary expertise to help them in system building. AI developers who are experts in their technical fields but not in the application domains. For example, a developer building a cancer prediction model will inevitably leave gaps when domain experts are excluded from the model that seeks to learn their knowledge. Now, the data quality issue that we report here of poor data quality from human-mediated data collection is only an issue if we think of domain experts in these limited, narrow ways. But if we were to reimagine domain expertise as an essential partnership throughout the AI pipeline, we can see new possibilities for collecting, modeling, and scaling knowledge. Domain experts can contribute to critical questions that impact model behaviors. What exactly are we modeling? What assumptions are appropriate? What features should be included in the model? What are we trying to predict, and how will we know? We call for viewing domain experts as full-range experts in their communities to find participatory ways to partner with domain experts in the ML lifecycle from problem formulation to measuring the impacts of these systems. And we discuss more in the discussion section of the paper. We argue that it's possible to view these perceptions of worker corruption and sabotage as acts of actually worker resistance to exploitative conditions of work. Modifying James C. Scott's memorable phrase, these are the weapons of the data collector. Now, instead of motivating an overworked health worker to do more work for dataset collection, one might ask how to help achieve their goals better, how to prioritize their numerous visits, better capture of their in-situ knowledge, allocate limited medical resources better, and build visibility into their contributions. Indeed, this is one way to realize the shared goals of both the AI developer and the domain expert on human development in low resource areas. Behavioral tricks for improving dataset collection like surveillance and gamification will only cause long-term damage and resentment among workers. A crucial step in this direction is for developers in AI to directly engage with field workers instead of interfacing with organizational leaders or NGO heads. As Lucy Suchman points out, work has a tendency to disappear at a distance, such that the further removed we are from the work of others, the more simplified, often stereotyped, our view of their work becomes. So with that, I move to the third part of my talk, which is a paper from FACT last year on reimagining algorithmic fairness when centered in India. This is again a collaboration with several Google researchers. Now, I just to connect the dots here, I spoke about data work and then moved on to domain expertise, and I'm now focusing on one of the central tenets to, or rather the central way in which responsible AI is operationalized, which is algorithmic fairness, which also tends to have an emphasis on model-based fairness and data-based fairness, rather than having larger interpretations and understandings of what it means to be fair for different communities around the world. Now, conventional algorithmic fairness, which is algorithmic fairness as we know today, makes several assumptions that are based on Western institutions and infrastructures. For example, a successful outcome from fairness research, which is bans on facial recognition, which has been widely implemented in many parts of the United States, including in Oakland, San Francisco, New Jersey, and has also gained traction in many parts of EU, comes from a concerted effort across decades of scientific research in the West, public data sets, APIs, and information acts for researchers to analyze model outcomes, an ML industry and research community that is fairly responsive to bias reports, and government representatives that are glued into tech policy, and an active media that scrutinizes the harms and impacts of AI systems. Now, we argue that the assumptions and about the relevance and the efficacy of these factors can fail and can even be harmful in much else of the world. Algorithmic fairness research remains rooted in Western concerns and histories, with subgroups like race and gender, data sets like ImageNet, measurement scales like the Fitzpatrick scale, and legal tenets that are often sometimes derived from American civil law. However, algorithmic fairness, as we know today, is increasingly espoused in AI policies in India, Tunisia, Uruguay, and more, and is increasingly copy-pasted into the national AI policies of various countries in the global south without paying attention to local contexts. Without engagement with the conditions, values, politics, and histories of the non-West, algorithmic fairness can be a tokenism at best and harmful at worst for communities. If algorithmic fairness is to serve as the ethical compass of AI, and indeed it seems to be the case, it is imperative that the field recognize its own defaults, biases, and blind spots to avoid exacerbating historical harms that it purports to mitigate. We must take pains not to develop a general theory of algorithmic fairness that is based on the study of Western populations alone. So in this paper, we ask, can fairness have structurally different meanings in the non-West? Could fairness frameworks that rely on Western infrastructures be counterproductive elsewhere? How do social, economic, and infrastructural factors influence fair machine learning? So we provide an analysis of end-to-end algorithmic power in India and provide a starting roadmap for algorithmic fairness when centered in India, and indeed possibly when decentered outside of any American or European country. So to answer these questions, we focus on India, the world's largest democracy. Increasingly, that's on paper, a multi-ethnic, multilingual, post-colonial nation, and the world's second largest internet using population. Despite several high-stakes AI developments in predictive policing and welfare disbursements in the country, there is no substantial AI research or tech policy in India. One of our key arguments in the paper is that the distance between models and disempowered communities is so large and this is through technical distance, social distance, ethical distance, temporal distance, and physical distance, that by simply focusing on making an AI model fair or the model output fair or localizing the model output for a particular community can backfire terribly on the community. So we point to three themes that challenge existing assumptions in algorithmic fairness when we center in India, starting with data and model distortions. Biases in models can be attributed to biased data sets. And there's a notion in the field of fixing the data set will lead to fixing the bias. But data can often be missing in the form of the digital divide, where half of India, for example, doesn't have access to the internet. And this excluded half is primarily women, rural communities, and Adivasis, who are the indigenous tribes of South Asia. Now, this was my prior body of work on gender equity online was motivated by how 2/3 of countries around the world have more men than women online. And in India, back when the research was conducted, only 29% of internet users were women. So this is evidenced quite recently during the COVID pandemic, when the government of India introduced a contact tracing application that was mandatorily imposed upon citizens. But only half of the country had access to the internet to even be able to download and log in to this application, which leads us to question the futility of digital systems that make assumptions on digital efficiency or data-based efficiency. And the whole fallacy of how fixing the data does not really fix anything in the real world. Data can be missing due to class, gender, and caste inequities in accessing and creating online content. So in other words, even when marginalized communities get access to the internet, they may not have full participation as other privileged communities do. As a result, any digital data is a representation of the privileged. Off-data practices are common in India, which happen outside of the network, say through phone calls, that may not count as data. Data can also be missing due to artful user practices to manipulate algorithms that are motivated by privacy, abuse, or reputation concerns. Socioeconomic and demographic data sets at the national, state, and municipal levels are frequently unavailable to the public, especially data sets that feature migration, incarceration, unemployment, or education divided by different subgroups. Now, these data sets are crucial for public fairness research, and to contrast, they are kind of widely available in the Western context, which leads to ease of implementing fairness research. Now, proxies, which are stand-ins for variables that are too sensitive to collect, but can be indirectly collected in machine learning, are similar to the West, but have different implementation nuances, being a pluralistic country. For example, a name, which is often collected in data sets for AI models and often used in fairness work, is the most semantically meaningful proxy, which can communicate caste, gender, religion, class, or ethnicity in the Indian context. Zip codes are heterogeneous, unlike many parts of the West, and particularly many parts of the United States, which have a history of redlining from racism, with slum, and whereas you may see that in many parts of urban India, there's slum housing that abuts with posh housing, which leads us to complicate how zip codes may not actually be synonymous with specific populations or socioeconomic indicators. Mobility has been reported to be much lower for women because of safety concerns, and for people with disabilities due to limited infrastructure like ramps. Traditional occupations may correspond to caste or religion. Proxies may not even generalize within the country, like asset ownership. Owning a scooter or a motorcycle in the city of Mumbai is very different from owning the same in a rural part of the state of Maharashtra, where the city of Mumbai is located, and can lead to very different conclusions. AI systems in India remain under-analyzed for biases, mirroring the limited public discourse on oppression. Now, this is starkly in contrast to how the anti-racism and even some of the focus on indigenous communities has come up to the mainstream, particularly with the Black Lives Matter movement in the United States. And in general, there seems to be a weak, but there is somewhat of a focus on marginalized communities in mainstream discourse in Western media. But we see that in Indian media, there is very little or absent focus on caste and other inequities, which leads to even fewer reasons for AI developers and industry to be incentivized to focus on measuring different axes of discrimination, identifying biases in their models and reporting them publicly. Now, moving to the second theme, which is double standards and distance from ML makers. Indian users are perceived as bottom billion data subjects and given poor recourse, effectively limiting their agency. Whereas industry and research is somewhat responsive to user bias reports in the West, in that a user of an application can go up on Twitter and complain about their complain about their issue, and if there is a likelihood that it might get noticed by a tech company or by academics and gain the visibility, and may even get fixed in some cases. But that is a completely non-existent scenario in a country like India. Recourse and agency of Indian users, especially those disempowered by caste, religion, or gender, is poorly addressed in AI systems. AI systems remove street-level bureaucrats, administrative officers, and frontline workers. These are the human infrastructures who play a crucial role in providing recourse to marginalized Indian communities. The high-tech illegibility of AI renders recourse further out of reach for these communities that are marginalized by legal or educational capital. Dalits are the most oppressed in the caste system in India, and Muslim bodies are used as test subjects for AI surveillance. As you see in this picture here, how human efficiency trackers, which are these wearables, are deployed among Dalit sanitation workers that are equipped with microphones, GPS, cameras, and a SIM card, leading to women sanitation workers avoiding restroom for fear of camera capture or waiting for the tracker to die before going home. And my final theme is that of unquestioning AI aspiration, where AI is aspirational and readily adopted in high-stakes domains, often too early in India. For example, the facial recognition system used by the Delhi police to arrest 1,100 protesters last year for the citizenship bill was known to have 2% accuracy and cannot distinguish between boy and girl children. Now, to contrast, a confidence threshold of 80 to 95% is recommended for law enforcement in AI systems. The statement from the state was, this is a software. It does not see faith. It does not see clothes. It only sees the face, and through the face, the person is caught. Now, setting aside the naive statement, algorithms may not be trained on subgroup identification, but proxies can correspond to Dalits, Adivasis, and Muslim communities disproportionately. For example, under trials in prisons largely come from these communities and from non-literate members. So in contrast to the focus on interpretability, explainability, and transparency in AI and machine learning research and even implementation, AI solutions in India have end-to-end opacity with unknown data, unknown model behavior, and unknown inferences, particularly those systems in the public domain. Now, I want to cite a paper by Shivangi Narayan and Vidushi Marda on data that's used in predictive policing in New Delhi. And the method of observation was, method of inquiry was to hang out in call centers and to observe the data that was being collected. by the call center operators. While that is a highly suitable method for the question that they had in hand, and the paper is worth reading, limiting to observational techniques simply because there is no other algorithmic technique, or lack of data sets, or lack of APIs and audit mechanisms, essentially renders several questions impossible to answer. It is highly unscalable and unsustainable to be able to interview and observe the practices of various stakeholders when the questions may lie at a more technical level. And so India lacks, or in addition to this, India lacks an effective ecosystem of tools, policies, and processes that can help stakeholders to interrogate these solutions. And this is a major impediment in ensuring meaningful fairness. And finally, tech journalism appears to cover app launches and their tech business deals and do not scrutinize algorithms and their impacts. Again, this is a bit of a contrast to media outlets like ProPublica and The Guardian, which have been instrumental in bringing public focus onto facial recognition and other surveillance systems that use AI, and hence have mounted pressure on AI developers to make these systems fair. So a fair ML strategy for a country like India needs to reflect its deeply plural, complex, and contradictory nature. And returning to my previous point, low resource communities in India may not even be aware that there is an AI system at play, or even a technical system at play behind their services. And so the myopic focus on algorithmic fairness that's based on models needs to go beyond simply the scope of models. Due to data and model distortions, we must combine data sets with an understanding of local context. The vibrant human infrastructures, such as the domain experts that I talked about earlier, point to new ways of looking at data as dialogue. We also introduce a set of axes of discrimination and fairness optimizations in the paper. That could be a starting point. Marginalized communities need to be empowered in identifying problems, specifying fairness expectations, and designing systems to avoid top-down fairness. India's heterogeneity means that fair machine learning researchers' commitment should go beyond model outputs to creating systems that are accessible to communities. Like the fatal Union Carbide gas leak in 1984, which was one of the world's worst industrial accidents, unequal standards, inadequate safeguards, and dubious applications of AI in the global south may lead to catastrophic effects for the populations. For fair machine learning research to be impactful and sustainable, it is crucial for researchers to enable an ecosystem in partnership with policymakers, civil society, and journalists. Context matters. We must take care not to copy-paste Western normative machine learning algorithmic fairness everywhere. And borrowing from Arturo Escobar, we must evolve pluriverses of AI ethics to flourish. So this work also went on to spur a whole new area on responsible AI in the global south, and there's a bunch of active work going on at Google on detecting biases in language models in the Indian context and other non-Western contexts. In the interest of time, I'm going to move to implications. But I do encourage, for those of you that are attending CHI, there's a bunch of outputs from our group which are highly complementary, and the focus, the agenda of the group has been on advancing and designing responsible AI in the global south. There's an upcoming paper on the work of data annotators in annotation firms. There's an upcoming paper at FACT on the limits of how accountability is framed, which presumes a relationship, sort of an adversarial relationship between users and AI companies, where users can demand answers out of companies, but that equation is simply fails in the Indian context, where users seem to have very little objectivity, even in abusive scenarios. And finally, there's another paper which is again very complementary to that on the high levels of AI authority that systems enjoy among populations in India, which can lead to blind faith, forgiveness, self-blame, and gratitude, which ultimately leads to high tolerance for harms from AI systems among user populations. So we empirically find that there's an enormous focus on model development among researchers and developers due to various incentives like publication prestige, how AI residencies are evaluated, and so on. AI education is now a lot more accessible, but remains largely focused on models, not addressing the real world challenges of collecting data or deploying and measuring systems, which practitioners are increasingly having to do. Some researchers that we spoke to report hacking model performance to look good for funders, clients, and conferences, with less regard for underlying safety or quality of systems. Now, this overt focus on models at the cost of ignoring important questions around the role of largely disempowered communities it leads to a very problematic case where AI models are increasingly seeking to intervene in domains where governments, civil society, and policymakers have historically struggled to respond. Now, this view that we report here comes from a conventional machine learning pipeline, which starts with an available, perhaps unclean data set and ends with model evaluation or deployment in a sanitized or a laboratory setting. It's clear that the scope of what we considered AI must evolve, particularly to be in step with what practitioners are actually doing on the ground. Metrics in AI are currently driven by concerns of machine beats human efficiency, cost, and outperforming the industry standard, which often relies on the expertise of AI developers rather than appropriate metrics to evaluate claims that are relevant to affected communities and phenomena as decided by domain experts and communities. Non-model aspects like data, expertise, labor, and meaningful safeguards for users are considered to be outside of AI, relegated to operations, whereas the elite status of AI system building is restricted to the high priests of developers, leaders of partner organizations, celebrity scientists, and bureaucrats, and disturbingly, the machine intelligence itself. Data work is undervalued despite its importance in AI systems. Essential experts are largely automated, reduced, or punished for dataset collection in order to build uber expert models, which may, by the way, displace these workers in the long term. The emphasis on model fairness offers a veneer of credibility for system builders, but when we examine closely, these frameworks appear to be dangerously symbolic and possibly harmful to non-Western communities in which they were not even conceived. We need to move from the idea of the model at the center to ecosystem thinking. While there has been much needed progress on introducing impact statements in papers, the NeurIPS datasets track, and a greater transparency and awareness around discussing human computation in papers that do make use of HCOM systems, a lot more has to evolve to reflect the on-the-ground practices in AI. Data work needs greater recognition and inclusion. How expertise is defined, who is considered an expert, how expertise fed into models is acknowledged and credited are all important questions to answer. We press upon AI researchers the need to develop more participatory stances and not the surveillance and control mechanisms that we discuss to extract more labor from already overworked field workers. Now, the question of unregulated surplus labor, which is this invisible labor that is not documented, poses new questions on who are the actual contributors to AI. There are long chains of humans that are involved in enabling model development in AI in low resource areas. How should attribution, transparency, provenance, and compensation evolve to include this surplus labor? Economic measurements of AI, such as the sample vision statement on detecting tuberculosis in 15 seconds instead of 10 days, measure the before and after effects of algorithms that are dropped into social settings. But they miss out on measuring how domain experts and workers were involved and drafted into hidden labor, and how communities and experts were displaced as a result, if they were, and whether and how expertise was redistributed as a result of the model. We need to expand the parameters of what gets measured and seen in order to fully understand the effects of these AI systems. Ultimately, AI systems need to be seen as interventions over existing infrastructures, not as sanitized experiments or toy experiments. I want to end with this quote from David Attenborough, the renowned conservationist, at COP26. Is this how our tale is to end? A tale of the smartest species doomed by the all-too-human characteristic of failing to see the big picture in pursuit of short-term goals, end quote. Whether it's climate change, industrial capitalism, or its modern offspring of AI models, can we start to see the big picture before it's too late? With that, I come to the end. I have a lot of people to thank. I'm happy to answer any questions. I think we have time for just a couple of questions, but this is my email if you want to get in touch.
Thank you so much, Nithya. That was such an inspiring and insightful talk. I literally have goosebumps right now. That was a very inspiring close to the talk as well. We do have a question that has trickled in, and I have a handful myself. So if you'd like to take them, I understand that one of our colleagues is a little unwell, so I'll just relay this question to you, Nithya. Agat, who's a PhD candidate in our group, says, well, thank you for this very interesting talk. Could you give some more information or examples about these field workers? For instance, who exactly are they employed by, for which task? And is it originally for data collection, for training, or is it for evaluating models? And why or why not are they in contact with the AI developers? So I think that's packed full of questions.
Good question. I mean, the answer lies at many levels. Sort of at a very, just in terms of context, field workers are employees or contractors of existing government or non-government organizations like community health workers who are employed, who are kind of government contractors. And they trickle down. There's a hierarchical system in which there are grassroots level workers. For example, one community health worker may be in charge of a few hundred families for the health and well-being, especially of mothers and children in those families. And so she may, in that specific model, she may travel to different villages, administer vaccines, administer health checkups, and track their pregnancies and child health outcomes and so on, and also be available for other concerns like tuberculosis and redirecting them. So she plays a very important role at the local level, and that comes from many years of building trust and expertise in her domain of public health, as well as that very sort of tacit, innate understanding that comes from at a local level of working with the communities and understanding their socio-political dynamics, how to navigate them, and so on. So in our view, a field worker is a domain expert because they have decades of knowledge and mastery over the subject matter, which the AI model eventually seeks to aggregate or to learn from. Now, the current approach in this field of AI is to take an already overworked field worker and have them perform this additional task of data set collection, which is not paid for, which is highly opaque to the field worker because they don't even understand why they're collecting this type of data. And data set collection for AI tends to be highly precise, mechanistic, and often time-based. It's very machine-like. And to have a domain expert perform this sort of work, which is often in conflict with their primary tasks, and they don't have an understanding of where this data is going, especially some of this personal data, and the rigmarole of entering data into forms and tablets, and not even being included in the AI system development of. Now, all of this is true despite the fact that AI's data, the ML data, plays in fact, probably the most important role in the success of the AI system, right? So data can determine, like I said, it can determine performance, it can determine fairness and various attributes. So it's really important that the data be representative and high quality, and because that's what the model is literally learning from. And but despite that primacy, we find that developers, and even though these are developers that are building in low resource areas where they're highly aware that there are resource constraints and that they are working with organizations, have no contact for the most part with field workers. So there's very little understanding of who the workers are, what are their workflows, is the data even accurate or reliable for practical purposes, and creating an understanding of why this data set is going to be used for what purposes in the downstream. Is that a good idea? Are the questions that they're asking, are the application ends sensible for those communities? All of this seems to be absent for the most part. And I think the reason why I say this question gets at multiple levels is because why this is absent is not a local phenomenon. It's I think a very structural issue in the field of AI and machine learning as to what is considered AI. The job of an AI developer is to build a model and to maybe publish a paper, maybe benefit from that model in whatever way possible. But expanding the pipeline, or even having an imagination of the data actually comes from human field workers or domain experts, and that we need to be talking to them, that's all considered to be out of scope for AI developers in our research. It's considered to be, oh, I never thought of that, or oh, that's interesting, I never thought of human beings being involved in my work, and I don't actually know how to do that, or I thought someone else would do that, this sort of passing the ball, passing the buck. So I think it has to do with a larger structural issue of what is considered AI, traditionally, historically in the field. But interestingly, even though historically there's a very technical scope that has been limited for AI developers, increasingly what we're seeing is the ambitions of AI developers are to develop these high stakes systems in areas that are extremely sensitive and unregulated, and areas in which they have no understanding, right? Because they're technical experts, like I said, and not domain experts. And so there's a huge gap between what AI researchers and developers are attempting to do in high stakes areas and what they're equipped and the approaches that they have and what education they have, right? Essentially, my answer is that they don't seem to be fit to build these models because they're making a lot of dangerous assumptions, and their approaches are uninclusive of domain experts. So this can all precipitate into something in the short and long term that that we need to observe, that may actually cause harm to communities. So it's a long answer, but it's a pretty complex question in my view.
Thanks for that, Nithya. If you can stick around for another minute or two, can I try and sneak in another question?
Yes, for sure.
All right, thank you so much. I was wondering, as you were, going through all those interesting projects, whether you had any insights with respect to how we could potentially scale up the inclusion of stakeholders. Because at some point towards the end, you were also reflecting on how, that's one of the issues. And although many of us are aware of it and, tend to try and acknowledge it, we're not quite sure how to move forward in scaling up this process of getting the stakeholders involved in perhaps the design of machine learning models that can impact societies at large, right?
By stakeholders, do you mean some of the local partners and so on?
For instance, so or maybe I misinterpreted it, but I thought you were reflecting on how it's difficult to scale up this process of acquiring input from stakeholders who are involved or impacted by the AI systems that are being designed.
Yeah, it's not necessarily difficult, but what we're reporting here is that there is no there is very flawed and sometimes absent interaction with different stakeholders. So the current relationship seems to be the AI researcher seems to talk to the head of an organization rather than trickle down further to talk to some of the people that are doing the actual work for the data. Right. And the head of the organization may have their own agenda and biases and their own views of workers and of how they want to partner with this increasingly, hype-filled AI, research. So they want to look good, essentially. I'm putting it very crudely. So that does not generate any understanding of the actual on-the-ground practices of the workers, as well as the work that is going into building these systems. So I don't think it is necessarily difficult. I think it is just absent. It is not happening today from what we are observing in our research. And as we know from areas like HCI, that there are scientific techniques and from various social sciences to engage with different stakeholders, different participants of the system, and to solicit their inputs and views into building these systems. Really, within HCI and CSCW, there's decades of work in this very particular topic on building technical systems with people. But yeah, there's a big delta between the availability and the access to those techniques, to those research methods, and what people seem to be doing in the field.
Right. And I think a lot of what you're saying also resonates with some of the work we're doing within our group. For instance, Agat, who's asked this first question, is also involved in leading some of this work, where we've been looking at how maybe some of the ongoing practices, as you said, and I agree, as crude as it may sound, that a lot of people might want to, get on this board just to check that box off to say, hey, we are taking care of fairness when it comes to machine learning. And, there are a lot of fairness toolkits that are now being shared publicly and developed, right? Maybe with true causes at the core of it all. But we were also wondering about whether there are any unintended consequences of these, or whether, to what extent some of these measures are taken just as a way to, a hand-waving sort of an attempt to avoid PR related issues, and to what extent this can actually, and maybe this is why, this perception that you mentioned about where humans are often looked at as coming in the way of model development, or stakeholders are coming in the way of model development, as opposed to really bringing them to the core of the design process, right?
Yes. Yes, so, I definitely think there's an oversimplification of by creating these frameworks and toolkits and so on, and applying them kind of without any discernment in different parts of the world, and just coming to the same conclusion that the model is fair.
Right.
Like I said, it's kind of laughable how you can have a fair model, but in reality, the community that's affected by that model has no clue that there is a model or that it is fair when, there are so many hops away from that model.
Right.
So we really need to critically examine these current approaches in responsible AI, which are designed for, I think there has been good progress in this AI, in this space, but it's very short-sighted. Because it's just limited to how a model performs. And that gives us no guarantees of different scenarios, or even, the limited understanding that an AI researcher might have in creating these fairness techniques. Like I said, because they don't seem to be engaging with the actual humans on the ground or the domain experts. And so there's a very narrow view of what is fair, what is even how do you even define fairness?
Right.
I think it's worth examining that. It's highly limited.
Right. Piggybacking on your generosity, Nithya, one last thing before we let you go. I was intrigued by what you said at the onset, where you were describing this context of high modernism. And I think you were talking about how, regardless of the success or failures of some of these AI systems and machine learning models, there appears to be some sort of a downstream impact nonetheless. And I was wondering if you can expand a little bit on that contextualization a little bit. I found that interesting, but I wanted to hear more.
Yeah, for AI projects in low resource areas, which often tend to be in high stakes areas like healthcare, climate change, agricultural, like predictions, crop yield predictions, and so on, really high stakes, sensitive areas. It kind of ultimately, the process matters, I think, a lot more than the output, because so the reason why I say regardless of success or failure is because let's say there's an AI model that's aiming to predict crop yield in various agricultural farms of a low resource country. Now, farmers may be drafted in as data collectors, and farmers may, these are already economically poor farmers who may also have to do some data set collection for the AI models, which they have no clue about. And ultimately the model may be making accurate predictions, by whatever benchmarks, by whatever tests the developer has. But it is possible that the farmer may never benefit from that model. Because even though their work has gone into that model, they may never benefit from crop yield predictions, or because it's so far away, and it diffuses so much. By the time it may not even get to the farmer, it may get to like agricultural scientists, or it may be other communities that are intended to benefit, or maybe other parts of the country that are intended to benefit. We have not. This is a pretty strong statement, I think, but we have not necessarily seen many good examples. I think I cannot think of any good example of an AI system which has directly contributed to the well-being of a community in low resource areas, where we can say that it has where we can say this is the causation of the result that we're seeing. I'm not talking about things like engagement or some of these other metrics. I'm talking about having straight causation where the model's output has led to an indicator in the field, right, where the community has benefited directly, has had a gain. And definitely we have not seen a loop where the contributors, the human contributors to these systems have ultimately benefited from the AI system. I think the evidence is lacking right now. And so that's why I say that the process is crucial. How these humans are involved, how these systems are architected, how their outputs are meant to flow, and how impact is measured, and how systems are kind of iterated and redesigned. Who are the beneficiaries? All of this seems really important, rather than just, quote unquote success or failure. And I would also critically question successful AI projects in low resource areas, because they're success for the sake of success, right? Based on the evaluation metrics that the AI researcher has developed, rather than, like I said, like where we can see that this has directly contributed to well-being.
Yeah. So would that mean we need to, obviously question what those success metrics are, and look at what the real values should be. Would you have any, thoughts at the top of your head with respect to what such indicators should really be about? Or is it something, I'd imagine that's very context dependent, of course, but is there something at a higher level of generality where you could say, hey, these are some, values that you should potentially always think about, or these are the right success indicators rather?
Yeah, I think I would abstract that a bit. So it's not so much. So yes, it is important to have good evaluation criteria and indicators to know how the system is performing. But I think there's a bigger question as to, is the system even needed for that particular metric, for that particular question at play? And what we are observing is that in the field, in the AI community, researchers seem to be building systems where there is good data and where there's a good, AI problem, and where there may be the sort of the appearance of socioeconomic benefit, right? When this is sort of the trifactor that goes into building a system, and that goes into, yes, if these factors align, then let's build a system, and here are the criteria. But I think it's even at the problem formulation level that success indicators are impacted at the problem formulation level as to whether the system should exist, and really getting an understanding of the context and understanding what do the communities desire, and what would be meaningful for them, not just as an AI, as a mathematical problem or solution, but it may be the case that the model is not even necessary. And like I said, I'm going back to something that I quoted earlier of, instead of overworking the health worker to do more work for AI data collection, one could, that is having them do all this work to, do whatever it is that the AI developer is aiming to do, engaging with the health worker to figure out what is of benefit to them and to those communities would lead to probably a very different problem and a very different solution, and hence very different success indicators, right? So I think there is that whole problem formulation process itself is extremely uninclusive, and it is done with some of the leaders of these organizations, with the elite members of the AI apparatus, and that leads to basically the professionals deciding what's a good problem for the solution that they have already. And so I hope you see that it's not the success indicators at a local level. It's the way this is done in as a whole.
Absolutely, yeah. All right. Well, thank you so much once again, Nithya, for being so generous with your time.
My pleasure.
We've gone a little over, but thank you so much.
Thank you all. Thank you for the great questions and for listening.
Are you going to be at CAI in person, Nithya, or is this going to be virtual capacity? All right. Well,
How about you, Ujjwal?
Likewise, yeah, same here. I'm going to attend virtually. A few of our students in the group are going to be there in person, so I was wondering if you would be around and they could come catch you. But
Yeah, this is
we'll
my
certainly
email.
cross. Yes, amazing.
Yes.
We'll certainly cross paths again, and looking forward to catching you at Kai. Agatha's here, and Agatha, I wonder if you want to say a quick hello to Nithya in case you want to catch her at Kai.
Yeah, do you hear me?
Yes.
Yeah, hi. Yeah, thank you for the talk. I think it was very interesting, and also the answers to the questions. Yeah, I had more questions. So I was wondering if you will be at Kai, maybe offline or online to talk more.
Agat, I think my email is best because I'm not really planning to stick around all of guys. It's too burdensome, according to me, to do this virtually. So I'm just planning on giving my talk and, keep it minimal. Email is best.
Okay.
Yes, and I'd love to hear more about what you're working on and what's coming up for you.
Great.
What questions are coming up?
I'll send an email then.
Also, thanks, Agatha, for saying hello, because Agatha's a little under the weather right now. So I appreciate her.
Feel better soon.
Soon, hopefully.
All right. Thank you so much, Nithya, again.
Thank you.
Have a lovely day.
This is a lot of fun. I really like the small group here and the atmosphere that it creates in terms of engagement and interaction. I really like that. Thank you so much, Ujjwal, for the chance to come share my work and hope
my
to
pleasure,
see you again.
Nithya. Absolutely. Have a good day and see you around.
Too. Thanks. Bye.
Thanks everyone for being here and keep catching the Academic Fringe Festival. Have a good day. Bye-bye.
Bye.
And then there are just you and me, Gala.
Yeah, actually, I get some